Hello everyone. In this lecture, we are going to see how to form a differential equation from the given parameter family of curves. So first of all, let us try to understand what do you mean by n parameter family of curves. First, let's see one parameter family of curves, that is y equal to kx square, which is one of the examples. Y equal to kx square, it represents one parameter family of curve because the presence of k makes it one parameter family. Okay, it means this family contains all these curves: y equal to x square, y equal to 2x square, y equal to x square by 5, right? K can be taken as any real number. So these are all members of this family. So this is one parameter family. Similarly, you can have one parameter family of lines like this: y equal to mx plus 1. Suppose if you take this one to be a constant, that is mx plus c, then we say it is two parameter family of lines. Why? Because you can find two independent constants here. And you can have examples of two parameter families, that is y equal to a into e power x plus b into e power 2x. This is also an example of a two parameter family. And you can take the most famous example, that is family of circles with different centers and a fixed radius. So x minus h whole square plus y minus k whole square equal to 1. So here I have fixed the radius and I am changing the center only. So h comma k are the parameters here. So two parameters are there, therefore I say it is two parameter family. And of course you can visualize this family. How? You take a bangle and you place it at different places, right? So you can find that family of circles there. So if you want to have one parameter family in this circles, you can do one thing. You can fix the center. So here I am fixing the center to be 0 comma 0. Now I am varying the radius. So here the thing which is varying is the radius only. That is the parameter here. So if you look at this family, which looks very beautiful, these are all concentric circles with different radius. Okay, and this is the family. Now you can have a three parameter family in the circles. It means you are going to change the center and also the radius. It means x minus h whole square plus y minus k whole square equal to r square. So h, k, r, these are parameters. Okay, so these are the things which are changing here. Okay, and this x, y, we treat it as a variable only. Okay, or in other words, we may treat y as a function of x as well. But if you observe that this h, k, r, they are actually representing parameters. It means you can treat them as a constants. Like for example, if I have if I give h equal to 1, k equal to 3 and r equal to 1, that gives me a number from this family. The member is, it is a circle centered at 1 comma 3 with radius 1. That is what. Okay, now let us see how to find the differential equation for this family of curves. So if you observe that here I have one parameter, so to eliminate this parameter, you differentiate it once and try to eliminate this parameter from those two equations. Okay, and here in this equation you have two parameters. So to eliminate these constants, these parameters, you need to differentiate twice. Okay, let me explain it here. Let me start with y equal to kx square. Now my aim is to find a differential equation which is satisfied by this entire family. Now to find that, you differentiate this once, so dy by dx, which gives k into 2x. Okay, so from this we can find what is k, and of course from the first equation also you can. So k equal to 1 by 2x into dy by dx. Now let me assume this is expression 1. Now substitute this k in first expression so that you get y equal to 1 by 2x into dy by dx. In other words, the differential equation which is satisfied by this family is nothing but dy by dx, which is equal to, oh, I think I have written something wrong. I substitute k, but I didn't write this x square, right? So this into x square, sorry. So now when you simplify this, you can cancel this x and x here, so that you will be left with so here you will be left with x by 2, right? And this side we have y. Now this one can be rewritten like this: dy by dx equal to 2y by x. Okay, so this is how you can eliminate constant. Either you can do it in this way, or the other way is this. So from the first equation you write k is nothing but y by x square. Now substitute this here, that is dy by dx equal to k into 2x, right? So if I substitute k here, so dy by dx equal to, this is y by x square into 2x. Now if you simplify this, finally we end up with dy by dx equal to 2y by x. So this is the required differential equation, and of course this is the differential equation satisfied by the given family of curves. Okay, since you have one parameter, we differentiated once and we eliminated this constant. Now let us look at the two parameter family, that is y equal to mx plus c, where m and c, these are two parameters. So now let us try to find a differential equation satisfied by this family. So for that, I am going to differentiate this expression with respect to x. If you do that, you will get m. It means here c got eliminated just by differentiating. Okay, or let me write the derivative of x is 1 plus derivative of c is 0, because c is a constant, right? So this implies, you came to know here, dy by dx equal to m. Okay, so now to eliminate this m, it is enough to differentiate one more time. So let me differentiate it one more time, so that you get d square y by dx square equal to 0. So now this is the differential equation satisfied by the given family. Okay, so you can rewrite it like this: y second derivative equal to 0. So this is the equation, the differential equation for the given family of curves. Okay, and this is very simple. And let me take some other equation, that is y equal to a into e power x plus b into e power 5x. Okay, now here you have two parameters. So to eliminate these two parameters, you have to differentiate it twice, and then you eliminate a and b, and you see what is the differential equation obtained, right? So differentiate this equation with respect to x, then you get a into e power x plus, now you know derivative of e power 5x is 5 into e power 5x, so this is 5b into e power 5x. Okay, now this one can be rewritten like this. So this y prime equal to, and if you observe that this a into e power x plus b into e power 5x, this is what exactly y is. So in place of this you can replace y, but you have 5 extra here. So what we'll do is, this 5 we are going to write it as 1 plus 4. So it means I'm going to write here plus 4b e power 5x. Okay, so this implies you end up with an expression like y prime equal to y, because this one becomes y, right? Plus we have 4b into e power 5x. Okay, so now from this you can actually write what is b into e power 5x. So what is b into e power 5x? or in other words, okay, b into e power 5x equal to y prime minus y divided by 4. So wherever you see this b into e power 5x, you can actually replace this y prime minus y by 4. Okay. So now actually in this expression we eliminated a, right? So now it is enough to eliminate b from this expression. So now let us do one thing. Let me assume this one as 2 or 1, right? So let us differentiate one more time. So if you differentiate 1 with respect to x, so we obtain y second derivative equal to y prime plus derivative of e power 5x, you know, that is 5 into e power 5x. So you have 4b into 5 into e power 5x. Okay. So now y second derivative equal to y first derivative plus, I'll do one thing, I'll write 5 outside and I'll write this expression here, that is 4b into e power 5x. Okay, so if we can eliminate this b from this expression, then we are done with it. And we know what is b into e power 5x. Here we found it, right? So now you substitute this expression here in place of 4b into e power 5x. So now if you substitute it, you will get y prime equal to, y second derivative equal to y prime plus, this is 5 into, this is precisely y prime minus 5. Alright. Now you bring this expression one side and you rewrite it. So this is y second derivative minus, this is 6y prime and plus 5y equal to 0. Therefore, this is the differential equation which is satisfied by the family, that is y equal to a into e power x plus b into e power 3x. Okay. So if you have two parameters, differentiate it twice, and from those three expressions, that is y, y prime, y second derivative, you try to eliminate those a and b. Okay. Suppose if you are given with a family which has three parameters, then in that case you need to differentiate thrice, and then you need to eliminate those three constants from those four expressions. Okay. So this is what we are going to do. And let us look at one more example, right? So that is y equal to a by x square plus bx. So this is the given problem, y equal to a by x square plus bx. Now you differentiate this expression. Let me assume this is 1. Now differentiate it once with respect to x. Differentiate with respect to x, so which gives me dy by dx equal to, and what is the derivative of 1 by x square? That will be minus 2 by x cube, right? So minus 2a by x cube plus b. Since you have two parameters, you have to differentiate it one more time, right? So let me differentiate this expression with respect to x again. So if you do that, you will get y second derivative equal to, this will be again minus into minus plus, this is 6a by x power 4 plus 0. Wow. So here if you observe that b got eliminated. Now it is enough to find a and substitute it here in the last expression, right? So now I'll do one thing. I'll make use of the given expression and the first derivative of y to eliminate b and to find out a. Okay, so let me assume 2. So here you have bx. So if you have bx here, you can subtract these two so that you will find what is a. Okay, so let me do one thing. Let me multiply this second equation with 2. So now multiply this equation with x. So 2 multiplied with x, which gives me x into y prime equal to minus 2ax by x cube, which gives me 2a by x square plus bx. And you know the given equation, that is y equal to a by x square plus bx. Right, now you just subtract one from another, so that you will get xy prime minus y equal to, here you have minus 2 minus 1, so that minus 3a by x square, and bx got cancelled. Right, therefore in place of minus 3a by x square, I can actually write this xy prime minus y. So let me substitute it here. So this is y second derivative equal to, you carefully observe one thing, here we have x square, but we have x power 4 here. So let me do one thing, let me write it as 2 by x square into, this is 3a by, what is it, x square. Okay, now you substitute this 3a by x square with this, but here you have minus, so be careful. So this implies, so y second derivative equal to, this is 2 by x square, here you have minus, so when you multiply with minus, minus xy prime plus y. Right, so multiply this entire expression with x square, so that you have x square into y second derivative equal to minus 2xy prime plus 2y. Now bring this expression at one side, so this is x square y second derivative plus this is 2xy prime minus 2y equal to 0. So now this is the differential equation satisfied by the family, that is y equal to a by x square plus bx. Okay, now let's do one thing. Let us look at one more problem, okay, where it is not actually given y as a function of x directly. It means y is implicitly defined as a function of x. Let me take this. Look at this problem. Find the differential equation of all circles which pass through the origin and whose centers are lies on x-axis. Okay, they gave actually family, that's why they are saying centers are lies on x-axis. So the given information is they are passing through origin. This is one information. Okay, it means when you substitute 0 comma 0 in that equation, in the circle equation, you'll get an identity on both sides. That's what this says. And the center lies on x-axis. Okay, it means when you assume h comma k is the center, so if you want this to lie on x-axis, then definitely k must be 0. So the center must be equal to h comma 0. And we know what is the standard equation of a circle, right? With center h comma k and radius r. So the equation is x minus h whole square plus y minus k whole square equal to r square. Here we know what is k. K is 0. So let me write it. So this is x minus h whole square plus y minus 0 is nothing but y. So y square equal to r square. So we are done with this point, that is center lies on x-axis. Next, they have given that it is passing through origin. So it means in place of x comma y, when if you substitute 0 0, you must get an identity. So let me do one thing, substitute 0 comma 0. So if I take x comma y to be 0 0, then I'll get 0 minus h whole square plus 0 square equal to r square. So this clearly says h square must be equal to r square. So therefore in place of r square you can actually write h square. That is what it says. Therefore the given family of curves are nothing but x minus h whole square plus y square equal to h square. So here if you observe that they didn't give us the formula explicitly. Okay, so they gave us some information. So based on that information we found what is that equations, family equation. The family equation is nothing but this. Okay, so now let us do one thing. Let us try to differentiate this expression and try to eliminate this h. Okay, so this is clearly one parameter family, right? So it is enough to differentiate this expression once. So let me differentiate it once. So differentiate with respect to x. So when you do that, you get 2 into x minus h, that is the derivative of x minus h whole square, and y square derivative is 2y dy by dx equal to the derivative of h square is 0 because it is a constant, right? So from this you can actually see what is x minus h. So x minus h equal to, you send it other side, that is minus y into y prime. I am writing dy by dx as y prime. Okay, so therefore in place of x minus h I can replace it. So here a h will be eliminated, and again here one more h is there. So to eliminate this, let me find what is h. So this implies h is nothing but you take h other side and you bring this guy to the other this side, so that you'll get h equal to x plus y into y prime. Okay, so let me assume this is 1. Now substitute this x minus h and h in 1. So therefore 1 implies, so x minus h will be replaced with minus y into y prime whole square plus y square equal to h square. What is h here? H is nothing but x plus y into y prime. Okay, so now let us try to simplify this. So here you can take y square common. So you take y square common. So y square into 1 plus y prime square equal to x plus y into y prime. Okay, so now this is the differential equation which is satisfied by the given family of circles. Okay, better let me write it in dy by dx form. So this is y square into 1 plus dy by dx whole square equal to x plus y into y prime. Okay, so this is the differential equation satisfied by the family which is x minus h whole square plus y square equal to h square. Okay, so I hope it is clear how to form a differential equation by eliminating arbitrary constants. Okay, so if you have any questions or doubts, you can contact me. Okay, thank you. Bye.